Okay, I'm going to work through the Spring 2010 EF151 exam number 1 for practice. I've got from the website the blank PDF file, and I'm going to work through this without referring back to any notes, doing all the calculations and talk through it and see how it goes. When you get your exam this semester, which is Spring 2013, you get to have a cover sheet, so you will not have an equation sheet. You can see what we had before. We will give you any conversions that you might need, so you don't have to guess and write a bunch of conversions on your equation sheet. You probably do want the constant acceleration equations down here, perhaps some equations that you don't remember as far as triangles, loss sine, cosines, and so forth. You can put practice problems, example problems, anything you want. Be sure to put your name and section, and if you don't know your section, you can look it up based on your TA and your time. Okay, let's jump right in. It's always a good thing to look through the exam first. So I notice here I've got a page of pretty short problems, and then some pages with a little bit longer problems. Looks like lots of vectors, and I want to be able to make sure I get through this. So I've got about looks like 7 or 8 long problems or longer problems, and that means I want to only spend about 4 minutes per problem, and I'm already 2 minutes into my exam. I haven't even started. So let's go back up to the top. The purpose of this first problem is, of course, to just see if you understand significant digits. This one's only 1. We have locator zeros don't matter. The next one is 3. This one is 4. And this one is 3. That 0 is significant because it's not a locator. Alright. Let's see. X component of the vector. Make sure you look for a coordinate system. And so we want the horizontal component of this vector. So I'm going to draw a right triangle here. There's the X, there's the Y. Alright, so it looks like this angle is 50. And so I'm going to use X equals the hypotenuse, 120 feet, times the cosine of 50. I could have used sine of 40. And I'm going to see that it's in the rightward or X direction, so it's positive. So I'll plug that into my calculator real quick. 120 cosine 50. Come on, calculator. It's not turning on. There we go. Always when you're in a hurry, it doesn't work. Come on, what's wrong here? Let's see. Let's reset this thing here. I bet it works better. 120 cosine 50. 115, 0.8, 116. Alright, we want to make sure we only give 3 significant digits. We want to make sure we give the units from right there. Okay. What's the magnitude of the displacement vector between S1 and S2? So the displacement vector we labeled as delta S, and it would be S2 minus S1. We're given those in component form. So let's write them out, S2 and S1. Alright, S2 is minus 30I plus 20J. S1 is minus 30I minus 7J. Alright, so we're subtracting. So minus 30 minus a minus 30 is 0, and 20 minus a minus 7 is 27J. Makes it pretty easy to get the magnitude. 27, we don't need a direction, we just want magnitude, and again remember units. Alright, so we'll put 27 feet there.